Among the most critical crop inputs in our industry is the photons that drive photosynthesis. And assembled here on our panel is industry leaders who provide the light to these crops. So for the next half hour, we're going to set aside the nerdy lighting discussion, the efficiency numbers, and the discussion on spectrum. We're going to talk about what's next and how we are maturing this space. My name is Eric Isley. I am the CEO of GrowFlux. We provide connectivity solutions and cloud-based automation technologies that rapidly scale farms of the future. Over 100 farms and 8 countries rely on our precision lighting controls. So with that, let's do some brief introductions.
Hello, and a big hello from our team from England. We've got quite a few here. My name is John Matcham. I'm the Innovations Director of the company. Going back to 2006, I was lucky enough to be one of the people that built the first ever LED lights to start testing very on plants. And that evolved out of something we were doing with animals on farms. We're here today, and in that time, we built one of the largest farms in the world. And out of that company came Light Science Technologies because we knew there was a whole lot more to do. And our target was going more with less. Have a different attitude, a different approach to our clients, and not just try and push brown boxes, but to partner with our clients around the world and help them develop the technologies moving forward. Today, we have a full-scale plant laboratory in the UK, 6 grow rooms. We have PhD scientists, plant scientists working on site, an electronics company in Manchester, which is producing all the electronics locally in the UK, so we're not importing from elsewhere. And last year we won a sustainability award for a lighting solution which will last you up to 25 years and is 98.5% renewable. So it's looking outside that, and then of course the challenge is temperature, humidity and CO2. And I'm used to wearing my head in my hands whenever I had that. And typically that's the baseline for most of the industry. We wanted to look at all 9 cardinals of growing plants and the interrelationship between each of them, and we subsequently started building an AI so that we could guide not only the plants themselves but the entire building and the energy efficiency. There were some interesting comments in the last one presentation where we were talking about HVAC systems. One of the sites we built has no HVAC system at all. It uses the ambient pressures, temperatures, humidity, CO2, all those things that Mother Nature brings, and that cut energy in half. So it's an interesting challenge ahead of us as we look at the technology. It's no longer about pushing boxes for lights into projects. It's about working in partnership with all of our clients.
Thank you, John. Blake?
I'm filling in for Ellis Johnson. My name is Blake Lang. I'm the Business Development Director for North America for Indoor Vertical Farms on behalf of Signify. Signify is the world's largest lighting company. We're based out of the Netherlands. We have a R&D facility over there called our Philips Grow-Wise facility, where we work with breeders and try different light recipes and different growth recipes on crops that are commercial and also non-commercial, and bring that value to our customers and make the mistakes so our growers don't have to.
Hi, I'm Dr. Igor Liss. A little bit about my history. About 25 years ago, I started what became the first LED lighting company, which was subsequently acquired by Philips, which is now Signify. And recently, in the last 5 years, I have started yet another company which produces lights, this time for horticulture. And we've made a lot of the same decisions and advances that we guided us from the first company. And we are bringing a level of control and precision to indoor and greenhouse growing that has been unprecedented, and we hope to do more of that in the future.
Great, thank you, Ober. So I want to start the discussion and frame it to the previous talks. So first we're going to touch on resource efficiency, and then we're going to quickly move on. So what emerging practices do each of you see moving the needle most significantly overall resource efficiency?
I think when you look at the holistic view of growing in a controlled environment, we're missing lots. We also charged into the industry 10, 12 years ago, started building small projects in containers, small rooms, and we were very focused, I think, on producing a crop that was financially viable. And there's a lot of stuff we missed. I'll come back on the HVAC thing a minute ago. We developed a site that didn't have any HVAC at all, and that cut the energy in half. As we start to look at nutrient provision into plants in detail now, it's no longer just about EC. We're looking about macronutrients, micronutrients, and being able to identify them so that on a minute-by-minute basis, the plant which changes its demand on the supply throughout its life is fed only the nutrients that it needs instead of pouring on tons and tons. We're taking now some of our technology outside into polytunnels, moving into the field. We typically talk here about CO2 as a pollutant. Some of the work we've been recently doing, we're discovering that there are actually some that are far more serious to us. Nitrous oxide, funny gas, actually is increasing dramatically at the moment through the use of nitrogen in field use, and it's actually far more detrimental to the planet than CO2. And also, the technology that we're working with our partners around the world, and these guys do the same thing, we're finding that some of the results that typical academia has found over the years have taken their measurements in daylight.
I'd just like to keep it focused on whole facility performance, how organizations are really driving that.
Yeah, one of the things that we really look at, Eric, is grams per kilowatt hour, right? And that's a real important metric that I think we all look at in the industry, is how much are we producing for how much energy input that we're putting into these facilities. And that's really a critical piece of measuring efficiency, I believe, out of these CEA-based facilities.
Mm-hmm. And another thing I'd like to touch on here is coordination across systems, right? Because the lighting system is now increasingly playing a larger role across the facility systems. And so Ohor, your company has quite a bit of experience in connected lighting, so I'd like to hear your thoughts on this now.
Yes, it's been really an interesting ride through the cannabis business for us. A lot of our work is in cannabis, less so in food. One of the things that we'd like to do going forward is do more in the food space. But cannabis has been a sort of a canary in the coal mine, or a leader in the space in terms of some of the things that we're deploying now more broadly. I think many of the first vertical farms were in cannabis, but we've also done a lot of indoor things in cannabis ahead of where broad adoption is going to be in other crops. And the one thing that we clearly needed to do, starting very early on, simply because we do a liquid cooled lighting product at Agnetics, is to talk about the interactive effects. And nobody was talking about the interactive effects. Nobody. The lighting was just something that you put up, and you got a quote, and the lighting guy didn't care about anything else. Nobody else cared about what the lighting guy was doing.
For the audience, can you go into a particular anecdote?
We kept seeing these facilities where, everything was everybody wants to decouple the facility, right? They, financially want to decouple all of the pieces and then bid all of the pieces out separately. That's been the traditional method by which all of these things have happened. And so typically when these facilities got built, the first guy would sell you the land, and you probably overpaid for that. And then the next guy was going to sell you the building, and maybe you overpaid for that, maybe you didn't, but you were already sharpening your pencil on that. Lighting was one of the last things to go in. The lighting budget is always on the chopping block because it's far enough along that when you run out of money, that's where you go looking. Sensors and production equipment, that's really hard later on. You're definitely out of money by then. And so when we talk about these holistic facility designs, unless you really are buying it all at once, that urge to shop it out and to chop up the building into all of these little pieces and say, yeah, I was going to do LEDs, but I can't afford LEDs, so I'm putting in HPS. And that happens every day still. There are people buying HPS today for that very reason.
Add something to that, and you're absolutely right. And lighting as an afterthought is a huge mistake. It really needs to be something that's right from the very beginning of the design of the project. I was working on a study for a client a few weeks ago, and they weren't convinced that putting 5 lights on the layer was better than actually putting 6. And because everyone had told them they needed 6. So we mapped out putting the light into a specific environment, and 5 of the same lights actually delivered more light to the product in a better way. But they had to have 6 because they wanted to go to 13 days high. And the reality is, if you take 1 lamp out and you take just 10 more centimeters of space to build 12 decks, you're actually 20% more energy efficient. And we really need to be talking, all of us, much, much sooner, and not thinking about light as the last bit with the number. Because you can actually, it's probably the most expensive thing you're going to spend money on. And if you want to put in monitoring technology so that you can actually make sure it's working efficiently for your plants, so that you're not giving too much light, you're not giving the wrong type of light, it's adapting and working for you with the plants, then it's important to talk to the lighting guys and the sensor guys really early on, because you'll be surprised just how much money we can save in energy efficiency, in capex, ongoing running costs, and actually improving in crop delivery.
Sure. It's actually a good segue into the next topic. Over the years, we've seen a certain amount of maturity coming to this space, and with a whole range of research organizations, standards bodies, and governments turning their attention to controlled environment agriculture. I really want to talk a little bit about how standardization is maturing this industry, and what we can learn from other industries as this space matures. What are your businesses doing specifically on that front?
I think for us, the Design Lights Consortium has really been a good baseline for us in standardization of horticultural lighting luminaires, and that's taken from the general lighting side. And I think before, for a lot of utility companies, horticultural lighting is very confusing. It's a black box. And what this has allowed most utilities across North America to do is to reference this list for approved luminaires. So that they have the UL rating, they have all of the correct testing that's required, and then that allows them to get an energy rebate. And that's one that I follow very closely as I can help our customers get a check at the end of the installation of anywhere from 10 to 50% of the capital costs of those luminaires. So when I can bring that to the table, they're very excited about that, as you can imagine. So that's kind of the baseline. I know there's several other entities that are working on standardization in horticultural luminaires, but that's really the main standardization that I'm looking at from a sales perspective, of course.
Yeah, and we're certainly seeing a lot of development among the professionals in this space. I mean, I was at an ASHRAE meeting not too long ago in Philadelphia, and CEA was the topic, and you saw a dozen firms that are now doing work in the space. So we're seeing standardization starting to grow across professions and across competencies.
I think we can take technology further than safety. We can look at the quality of light that's coming from luminaires to maintain that when you're buying a product from any producer in the world, that the light that's coming out of it is the same from the next to the next to the next. we have our own testing facility which we built, which measures quantum power and CIE simultaneously. And we tested some products, and none of the products that came here, but we tested some that came from certain environments. And in one particular product, we have 15 different spectrums coming out of exactly the same luminaire from the same supplier, from the same batch number. And that's a real worry. If, and these guys, I'm sure, will appreciate and agree with me, is the cost is constantly being pushed down so that we can meet certain targets. But it's not about the cost, it's about the quality that is actually going to be delivered to that crop. Because if you want a reliable crop, you need to have a real quality crop.
Yeah, I'll agree with that. I think that the regulation, I've experienced a lot of the birth of regulation of LED products, and I must say it's been fairly gut-wrenching. I think that we're still treating LED products as though they were incandescent lights from the 50s to a large extent. I think the last batch of regulations has been fairly heavy-handed and not as supportive of the industry as it could have been. I also think that the gut feeling that we need to regulate everything is counterproductive in many ways, because I think that the things that are easy to regulate are not necessarily the things that are the most impactful. So if we look at products that people are deploying in various industries, not just in lighting, we mandate more materials and more structure to a lot of these things than is really warranted. If we had rules about how to build a mobile phone, we certainly wouldn't have the mobile phone we have today. But there are really no rules as to how to build a mobile phone. And yet when we look at, that's something that's in your pocket all day long. It's probably the closest thing that could do you the most harm. And yet, we have lights and a lot of other things in our world that are very, very much more regulated. And I'm not sure that we're getting as much benefit out of that as we should. I appreciate the efforts of a lot of these organizations, but they tend to become self-fulfilling, expanding projects. And that's not always in the best interest of the consumer or the industry. So more care.
Fascinating perspective. I'm just going to shift gears a little bit. Talk about data and analytics. Emerging themes such as crop steering aim to manipulate the environment for certain crop outcomes. And initiatives like the Power Score at Resource Innovation Institute allows growers to anonymously share data to better understand their resource efficiency. So I want to know, within your organizations and among your customers, how is data changing the industry, and what direction do you see these increasingly maturing data and analytics solutions taking in this space?
Yeah, data, that is a loaded question a bit. What I come across a lot is a lot of data siloing in these facilities, right? And the data warehousing is not just talking to the other data sets. So I think that as an industry, we can do better is combining all of that data, and the Power Score is a great metric that's being used as well by the RII. But I really don't think that a lot of people are really there yet. I think we have a long way to go, and there's a company that is doing something as well. It's called Let's Grow, that I'm familiar with, and I think some of our customers are getting on that platform and sharing information. And then I think from that information we can make best decisions and steer our crop in certain ways to maximize efficiency.
We've been, for the last 3 years, building an AI solution, and we've got a one of the sensors here at the moment, which is looking at all 9 cardinals. I think the easiest way to understand the question and where the answers come from is if we'll just close your eyes for a second and think of a bubble in the air in front of you. And imagine those 9 cardinals. And if you don't know what they are, I'll tell you quickly. In the air there are 5. So there's air, speed is one of them, it's really important. Never really look at it much, but ask any glasshouse person, air movement's really important. And there's a correct speed for the crop. Temperature, humidity, CO2, of course, light. And the 4 in the ground are dissolved oxygen, nutrient, water, and root temperature. Typically, as I said earlier, when you look at temperature, CO2, and humidity, we need to join all those things together. So let's go back to this bubble for a second. If you can see this bubble in your mind, there are 9 tags on the outside of it. They're not all equal. They don't all have the same amount of influence, and some of them work together, some of them don't. If you move one, change one, the others are going to change too. And there's nothing that stops that, that's just nature and physics. The question we're answering at the moment is, if you grab one of those tags in your mind and pull it, you no longer have a perfect ball, you end up with something that's like a teardrop. What do the other 8 cardinals have to do to put it straight and put it back to where it should be? And part of going back to what you were saying earlier on, light was the last thought. Light is probably one of the most influential, but it's not the all and everything. And without working in conjunction with the other 8 cardinals, you can put the best lights, the most expensive lights into a facility you like. But if the rest of the system isn't working hand in hand with it, your crop will not be any better than anybody else's who really doesn't know what they're doing. And it's really important that work, we and there are other organisations around the world that are doing that. The data is important to share because each time somebody or somebody's system learns something, it tells the rest of the systems where they're making their mistakes. So you might be growing bananas in the Bahamas and you want to know how to do that in a close environment solution on the other side of the world. Let's say Iceland.
Jump in real quick. Now, sharing that data, I mean, in the cannabis space, we saw power store develop pretty quickly. A lot of good intentions to reduce carbon footprint in that crop. But here in this space, we have much more vertically integrated companies that want to own more of the stack. And so, when we're talking about sharing data, whoever has the most data and the best trained models,
it's an interesting position, but I've spoken to some of the biggest growers in those people, and none of them has come out with that response. They've all pretty much said, actually, we need to, the term we've been using over the last few months, certainly last week or so in Amsterdam, it's about growing the pie, not the slice, because the industry is so early. So I'll change it for New York. It's about growing the pizza, not the slice. And I think we need to work more together at this stage. The market space is huge, and there aren't that many of us. So at this stage, if you want to become the company that was Philips, that was around for 100 years, you're not going to do it in this industry on your own. It's an entirely different industry. We need to work more and more together to expand that in partnerships with clients and growers around the world, so that we can accelerate the industry quickly. Because if we don't, we'll run out of their speed and ideas fairly quickly.
And we've found that there's a huge benefit to data even before you get to artificial intelligence. Any intelligence at all applied to data very quickly yields results. And we've seen that by capturing even just some of the parameters that we talked about, and we capture many of those, maybe not all of them. But having them in a system that's not a lab notebook sitting outside of the room, where someone else from a different city or that's still at home can log in and everybody can look at the same data at the same time. We've found that the growers are very, very open to the social aspect of that data. If you can get 3 guys on a Zoom call looking at the same screen, you immediately understand that there is value to everyone looking at the same data and making a decision collectively, looking at the plants, looking at the pictures that are logged over time, looking at Zoom video calls seem to be very helpful. for example. So before we ever even get to artificial intelligence, which is going to be a whole different topic and a whole different set of discussions, there's an enormous value to having 3 or 4 growers look at the same crop and try to understand what's going on and how to do better. And this has been going on in agriculture for I think centuries, right? Every state in the United States has an agriculture department at their university. And part of the value of that is when their agricultural industry needs help, there's a place to go to get it. And that happens all around the world, right? The ability of someone that sees multiple farms, multiple locations, multiple problems, to look at what's going on in a new place and quickly come up with the answer is way higher when we have the ability to visit and to see, and we can do that virtually now, and that's a huge advantage.
Yeah, I agree. We've seen within our own business how cloud connectivity has really driven collaboration, especially in the wake of the pandemic. My concept of farm from home collaboration is worth its weight in gold for these businesses.
It also changes the way we work with plants. Traditionally, pretty much all growing is a response to whatever happens. What this data is giving us the ability to do is be proactive. So instead of seeing plants start to wilt because there's a break in the water line somewhere, we know straight away because the sensor is actually telling us where the fault is, and we can get to it much quicker, which means yields are much safer and more reliable than finding out because the plant's already halfway dying.
All right, just moving on. I want to talk a little bit about scaling. So the vast majority of crops that are grown in indoor agriculture are grown either in a small facility or in, perhaps we'll say, like an early generation facility. So I want to know, from your perspectives, what are the things that need to happen to help scalability get this industry to where it needs to go, reduce the amount of pain in scaling for the customer, and then, to the extent possible, if you're experience here, one aspect that has been discussed here is the fact that a lot of the energy availability is not often co-located with the demand. I want to hear how your businesses are helping customers on the topic of scalability.
I think site selection plays a big role into that. I think if you look at the indoor vertical farming space, we have a lot of competition for this warehousing space with Amazon across the world, and particularly in the United States. And power availability is not always there, so we have to look at alternative power generational sources, possibly. I think that site selection is very critical to that.
I think there's in site selection, and that's complicated enough by the fact that the infrastructure for power, certainly in Europe and here in the US, isn't what it could be. So location where you find power is the first thing. The other thing, of course, is if you're looking to reduce the energy usage within the building, finding the right locations to put those buildings so that your minimum maximum temperatures are there. It's great to be able to say I'm going to build in a particular city because it's cool to do so, but actually as a business proposition, you're probably better looking at a site where your extremes of weather are not as bad as they might be in one place or another. And then obviously you've got to find some way to join those two maps together and find where the two things coincide, where you've got power and a suitable environment to build one in, where you're going to be most profitable.
One thing that we try to do is maximize all of the photons that are generated from the lighting system and make sure that the crops are receiving those photons. If you look at the system architecture inside of, say, indoor vertical farms, the most typical racking systems that you see are kind of the standard industrial racks, right? But a lot of times if you're in those facilities, a lot of those photons that are generated are escaping from the sides of the racks.
So I think system architecture can really help with that power issue a little bit, and we can maximize efficiency in that way.
Yeah, certainly the entire country of the United States is essentially out of electricity in large swaths of where we would like to site these facilities, right? So if we want to put facilities near the major cities, you know, certainly everything on the West Coast is essentially out of electricity. Like we really cannot build food production greenhouses and not take that into account. And it'd be really nice to have the utilities work with lighting, HVAC, and the agricultural companies themselves to try and make the impact on the grid at least controllable. You know, a lot could be gained by making that impact controllable.
That's what census would want too.
Yeah. The plants are really tolerant of small changes in lighting and environment. The big changes are more of an issue, but small changes, which could be very, very helpful to the grid, you know, are something that is a wide open space. To my knowledge, nobody's really successfully implemented that. But you know, the impact of a 10 million square foot greenhouse on the electrical grid is much, much larger than any of the demand response programs that utilities are working with today. And it's one guy you have to talk to.
Mm-hmm. Yeah, and we're very much involved in that conversation. You know, when we talk about topics like demand response, where utility companies pay electricity consumers, they pay them to turn that dial down. Traditionally,
Not enough.
Right.
Not enough. It's not enough.
Well, it's certainly not enough, but like to point out, in agriculture, you know, we talk to demand response professionals, and you know, they are used to seeing office lighting come down 10%. In horticulture, we can bring loads down a whole 90%. We can then further even shape the load throughout the day, because those crops are very tolerant to changes in the production.
Yeah, one of the things that's happened in the energy sector is that we've separated out the different components that you make when you produce power for the grid. And what's happened is that the actual energy part is free now. You know, solar is so cheap. You know, the payment that solar guys get for the actual electricity is pretty close to zero. What's really valuable is regulation services. So that's the ability of the utility to say, no, I need that power now. Like, not like you have to deliver it. And then to be able to throttle that up and down quickly is very valuable. And I think that these larger facilities can actually provide that in a way, you know, from a demand perspective, the ability to scale that demand very quickly is super valuable. And as far as I can see, no one's there yet. We'd like to be there.
Right. Well, we are out of time. Thank you.
Thanks, Eric.